Good morning and welcome to Science and Innovation Day 2019. This day is made possible through collaboration and co-creation between 3 different research centers at Mid-Sweden University, together with Processum, RISE, Fiber Optic Valley, and Mid-Sweden Chamber of Commerce. And of course, thanks to all of you guys who are joining us here today. A warm welcome to all of you. This year will focus on co-creation, transformation, and artificial intelligence. Artificial intelligence is definitely one of the hottest topics in society today. The transformation is here, and we sure need to learn how to co-create together to face all these different opportunities and challenges, both that we are seeing today, but also tomorrow and further on in the future. My name is Lisa Maria Norlin, and I will be guiding you through this day. And with us today, we also have some live viewers from YouTube. So if you have friends who are not here, but they are next to a device somewhere, they can go into YouTube and look for Mittuniversitetet, and they will be able to see our keynote speakers here today. The YouTube viewers and all of you in here should, of course, also join us in the co-creation when it comes to our conversations that we're going to have today. And helping us with this, we have Menti. I'm sure most of you have used this before, but you enter menti.com, you use a code specific for this event. And when you enter that code, you have a question that you can try. How are you feeling today? To make sure it works. And then when the keynotes are speaking, you can send in your questions. So please text your questions, and we will be able to ask the different keynote speakers about what you're thinking about today. I also have a challenge for you. For co-creation to happen, you need to have a network of people who you usually do not meet on a regular basis. In the program today, we have a lot of time for you to meet each other, to talk, and have a good time, of course. When you do that, the challenge I want to give you is that make your own list of like 5 to 10 new contacts. You never know when these people are going to be useful and be of value to you in the future. And when you introduce yourself, tell them why you should be on their new contact list. So you can practice that. What is your pitch? Why should you be an important person, perhaps, for this, for the rest of the people here in the future? The program. We have it here, but the web page is a perfect place where you find it, scienceandinnovationday.se. We have a lot of things happening and going on today. And after we are done with the keynotes, we also have all the parallel sessions. And that's also new this year, that we have at least 5 parallel sessions at a time that you may use. When you look at the different parallel sessions, pay notice to the fact that some of the titles are in Swedish, and that means that the seminars will be held in Swedish. And if the title is in English, they will also be held in English, so you, if the language is important to you. I will get back to some more practical details later, but I think we all are really curious and excited about our first keynote speaker. So when we listen to her, don't forget to text your questions to Menti. The founding team of Refine Technologies is a true example of co-creation and collaboration. It's a team who plays a role in the transformation that we are experiencing. They have created a scalable system for classification and sorting that can be applied to basically any stream of objects. They have built the first automatic battery sorter using AI and have commercialized the world's first reverse vending machines for batteries, as well as introduced machine learning into the fishing industry. Let us learn more about this journey and this amazing technology. Welcome our first keynote speaker, Johanna Reimers, CEO of Refine Technologies. Welcome.
Hello, thank you very much, Lisa Maria. Very nice to be here. Well, as Lisa Maria said, I am going to talk about how to use AI when sorting and identifying batteries, fish, and various stuff in between. I will give you a brief intro to what we are doing at Refine, and then we will go through 2 cases of innovations that we have done. As was mentioned, the battery sorter and also the 2 fish applications that we are working on. So here is the little team. The guy in the middle is actually an alumni from the Mid-Sweden University, but not from Sundsvall, from Östersund. But anyway, so we are a technology providing company based in Gothenburg, and we were founded in 2014. We have installed equipment around the world, and we are using cameras and computers with artificial intelligence software that can be taught to recognize things based on their looks. So it's a normal camera, it could be any kind of camera, and it's just looks. It doesn't see through, it doesn't have any material sensor inside of it, but it can be quite powerful anyway. To start with, I will show you a short trailer about us. This is our building, office building. Let's see how it works. Okay, that gave you a quick overlook of what we're doing. So to start with the first case, how did we develop the optical battery sorter? Well, it was almost 10 years ago that this started as an artificial intelligence project at Chalmers University. And the idea was then to use artificial intelligence to sort waste and in particular used batteries. The project became a company, OptiSort, and then later on that company was transformed into Refine. But the people involved in this, my co-founders, they were all with the project from almost the very beginning. And we had 2 pilot customers, one in Sweden and one in the UK. And the Swedish company, they were part of this project in a very early beginning, which helped us a lot because there is no way you can do anything without getting your hands dirty, in this case very literally by digging through tons of batteries to create a database of batteries and how they look, the labels of batteries. This is a battery, if anyone doesn't see it. But in order to recognize these and sort them into different chemistries, you need to have the look of them, because you need to look at the label. So we have taken millions of photos of different battery labels. And that was the first challenge. Can we really tell that many labels apart? What if they're dirty? What if they're worn off? What if they're actually, well, they could be completely naked or very anonymous. And once we had solved that question, that challenge, well, after that, it was all about how to line them up as fast as possible. So that was a mechanical challenge. And that was the and that has been the, you can see it is tricky because they are cylindrical, so they will just fall off any given angled area. And anyway, the first version we had was a shaking table, and that works, well, you have various vibrators and then carpets with angled carpets. So when they shake, the angles of the carpet will make the battery rotate and then go onto a conveyor belt. A very commonly used feeding method. However, that was a very bad way to treat dirty batteries. It was like a dirt collection area. So every piece of dirt or moist or water that came into the process ended up in this carpet, which became like a concrete carpet which couldn't shake or transport anything. So that was a kind of a bad process design. The quality was bad. We got very low capacity, and and also very bad sorting quality on top of that. So the customers were not very happy with it. We had promised that it would sort 5 batteries a second, and we were happy if it sorted about 3 batteries per second, which was not really competing with the manual sorting. So, and on top of that, it was impossible to clean this mat without disassembling it. So we didn't want to sell more of those because that would only give us more problems. So we had to come up with something new. We called it Gravity, and we used Gravity. So as you can see here, well, it's like 3.5 meters high. So we had an inclined conveyor pulling batteries up, and then through an advanced system of various V-belt conveyors, V-conveyors, and other small conveyors, and a slope, we use Gravity to accelerate batteries going down and ending up under the black box, which is the camera unit. It was great. It had double the capacity. We improved quality also by introducing something that we call recirculation. So if the camera or if the machine was not sure enough about the classification of the battery, we could give it another round or many other rounds, and it would get a second chance, because some sides up are quite anonymous, as I said, so it can help to look at it an extra time. This was easier to clean and maintain, but it had a lot of moving parts, and there were many places where small items could get stuck. When you work with any kind of waste material stream, you don't know what will end up in your stream. People will throw anything in that. If it says hazardous material, they will throw syringes and bullets and light bulbs and nails and needles and all those things. And although we required a pre-sorting before things entered into our machine, you cannot really be sure that some things will not end up there anyway. So there were many areas where things could get stuck, and that would cause downtime. And then on top of that, it was a very bulky design. It was difficult to ship. I think we had to ship the first machine like this in 11 different packages. So it was, it had a lot of problems with it. But anyway, we managed to sell a few of these and install them and so on. But we noticed that there were a lot of different maintenance complaints. So we thought of a third version, which we called the step feeder, and that works as a step feeder. You saw it in the movie before. It will have fixed steps and moving steps, and it will push things up, and eventually onto a sorting conveyor belt. And it sorts about 1 meter of batteries per second, which is about 10 batteries per second. And that is half a ton per hour. We knew from the beginning that a step feeder design was very good in many aspects, but it was just impossibly expensive until we found a small English company that we could work together with. It was like it was even smaller than us. They were only 2 people in that little company, but they were very good at producing things at high industrial standard. So it was now a minimum of moving parts. It's easy to ship. It's 2 packages, and most of these components are standard. And we've also added some other software things to this, but it worked very well. And we have installed this in Norway and are about to install another one in Australia by the end of this year. So to conclude, it is absolutely key to try everything in real conditions. All of these, all of the first 2 versions, we thought that they would be optimal design, very good, would do the work, and so on. But it was not until we actually tested it, had batteries go into the system and see how it could handle them, that we noticed that, well, this was not as good as we hoped, or this was totally unexpected. I know for one of the first customers, we saw that, well, dirty batteries is a problem. Let's wash them. Let's clean the batteries. Let's have some sort of small shower that they go through before they come into the system. That just added a whole new dimension of problems, because water is a media that will just go into everything. So anything that was not dirty before became dirty. It was like a dirt distribution method, so that was a very bad idea. But anyway, I'm not going to talk about all the bad ideas because that will take forever. Anyway, the key here was to have a very close collaboration with the pilot customers and to try to go into brainstorming as a troubleshooting method instead of blamestorming. I know we ended up there both internally and externally sometimes, but in the end, we managed to find a common way. Anyway, let's go over to the. I think I'm going to skip this. It's about it's another movie about the machine, but I've talked so much about it, so let's skip that one. And go into the fish industry instead. So we have 2 examples. It's a fish face project, which was initially started by the Nature Conservancy. It is like a project where they are trying to do an inventory count of the fish species in the Indonesian seas, and where we are helping them to do this automatically. And the species grade is a product that we have developed thanks to the fish face project, you could say. It's a more of an industrial application. So a few words about the Nature Conservancy fish face project. In 2015, I got a phone call from an American contact of ours, which we had met because he was involved in developing one of the first type of reverse vending machines for phones, you could say. Eco ATM was the name of it, where you could hand in your phone and get cash. And he knew about us and our technology. So he gave me a call and he said, could you recognize different fish species? Yes, of course, but why and how, what for? And then he started talking about the Nature Conservancy and their fish face project, which had been going on for a while. They were taking photos of large catches by the fishermen, and then they had experts going through the different images. And for me, the fish, they look either red or gray. It's either a snapper or a grouper, but there are hundreds of different subspecies. It's in Indonesia. That is one of the largest fish faunas that we have in the world. So naming those by their Latin first, middle, and last name is not something that any common fisherman can do. They have their local names on their fish, of course, but to get the Latin names needs a fish expert. And that was a very time-consuming and difficult task. So they were asking us if we could do this automatically by training a classifier. And that sounded like a very interesting project. There was no budget or anything like that, but we said, well, if you can feed us with images, we can try this on our software. So how would we get access to any data, photos of fish? And how would we make sure that those photos were possible to use? How would we measure the fish length? And how would we know where they had been caught? And how would we do this project in Indonesia to start with? That was very far away from Gothenburg. But as with everything, you need to start simple. So we designed a very simple, let's call it a fish photo booth. It was a white table with a roof on top of it where you could place a smartphone camera. So they could use a simple smartphone. We developed a small app so that we could run a classifier on the photos that were taken on with the phone. And by doing like this, we got a consistent background and a consistent distance between the camera and the object. And what you see to the lower right is a segmentation. It is where the classifier defines what is the object in this image and what is the background. This was something that we did not have to deal with for the battery sorter, because batteries have standard sizes. And we had a size sensor before each battery went under the camera, so we could say what kind of size of the photo frame we would have, and then count everything that came into the picture, so to say. But that would not help for the fish. They would have very different sizes and of course, shapes and so on. But anyway, we asked them to collect images, at least 50 or something of each. We didn't know how many were needed, but as many as they could get. And so we did a small proof of concept, and it worked. It was not difficult to recognize the different fish species, but it was very difficult to collect photo images, because this was, of course, not part of the routine of the daily fisherman's work. It was probably not very good for the fish. I mean, it's food, it's valuable, it should be handled gently, so you don't want to add any extra activities around the fish. So we had to think of another way, but, well, this was a proof of concept. We could say that it worked. Now we just needed a budget. And that, in that sense, we were lucky, because in 2016, a year after the first phone call, we won the Google Impact Challenge Award together with this project. So Google handed out a bunch of money, and that could start the project. So then we designed something that should work on board a boat. We had challenges when it came to internet connectivity, to electricity, to how to trust the standard of the components, and to not interfere with the daily process too much. But we started simple again. So the first one to the left here is a styrofoam prototype, which we built just to make sure that, well, mechanically this will work, this will do the job. And then we had one built in metal. And as you can see, there is a light inside of it, so we know that we get a consistent light for each photo. And then there is a lid in the bottom, so we could place the fish inside the mailbox or the box, and then take a photo and then release the lid, and it would fall into some sort of box or ice box or whatever it would be falling into, but you wouldn't need to lift it again. And the image on the right is when we installed it in Indonesia on a fishery site on land. It worked well, so the next step was to put it onto a boat. And you can see here, these are the photos that my colleague sent me when he was visiting Indonesia, and the boat. It's not a high standard boat really. And it didn't have lots of floor space. It was no roof or electricity or anything really. It was very basic. But well, we didn't need electricity all the time. We didn't need internet all the time, and we just had to deal with the water and salt water everywhere. There are solutions for that. So we did not expect mice, but that was a nice surprise after the first installation. They are apparently like cables, but yeah. Anyway, that was easy to replace. So a year ago, we actually had it installed. You can see they actually chose the spot there on the lower left to install the little unit. And that's my colleague in the middle, and two of the guys in Indonesia. And this screen dump here is our online monitoring tool, you could say. We can see what what photo has been taken and what is the classification, and then there is things that is not possible to read, but it's the geographical location and the estimated length of the fish, which will be an estimated age of the fish, you could say. The length is correlating to the age. What happens now is that, well, this was a good start. We showed that it worked. We're out of budget in the project, so now the Nature Conservancy is doing another round, and the aim is to install this on many boats to see if we can scale up the collection of data. And here's just to give you 10 seconds of a feeling of how it is on board this boat. Yeah. Anyway, that entire project led to another phone call this time from a Norwegian sales guy. He sold equipment to the fishing industry in Norway, and he wanted us to do an industrial application for the fish species recognition, and to install it on a boat like that one, for example. And boats like that are 60, 75 meters long. They are floating factories. They go out in the Arctic Sea for 4 weeks, come back with 800 tons of packaged 400-gram fish packages on pallets. So it's very automated process, but there are, of course, a few tasks that are not automated, and the species recognition was one of them. So this, and of course, it had a very high, very different demands on the the reliability and on the industrial grade compared to the Indonesian hobby project that we had been doing before that, you could say. So, but this is what we did. The thing in yellow there is our machine. It's not yellow, but it's just to show how it looks. And the other part of the machine was already in place. So the weighing and the actual physical sorting is taken care of by another company, and we are just doing the photo and the recognition. And the picture to the right is our unit installed at the boat we saw earlier. And it came back last week from its first trip. It has now been collecting images, thousands of images of various whitefish. And now we are adjusting some of the things that can be improved, because there will always be things to improve, especially on a first trip. Make sure that the lens is okay, and make sure that the light is okay and stuff like that. But that, I think that will work, because this time we have the right partners. We already have a sales and maintenance partner in Norway, and we have also a manufacturing partner. So this will help us a lot. If you're such a small team of people, you cannot really do all the things yourself. So you need to partner up, and that is also the main conclusions in this. Of course, you need to do what to do. You need to know what to do, but who to do it with as well is just as important. So the overall conclusions is, well, find good partners, test it in real conditions, share risk and success, and keep a close and open collaboration, because otherwise you will never solve any issues, because there will be issues. It will be lots and lots of issues. That is the only thing you can be certain of. And then I think you're very well equipped. Thank you for listening.
Thank you so much.
Lots of questions.
Yes, we should have a seat here. Let's see if I fit in. Well, it's amazing how you can use basically the same type of innovation and technology in different areas. Is there another area that you already are looking into, or are you still with the fish and the batteries?
We get a lot of requests for various e-waste, and that, as with everything, when it comes to the recognition part, that is quite easy, but the physical handling is the most difficult part. That is the main challenge when it comes to most of these. When you are going to replace a human activity, you tend to forget that you also need to replace the arms, not just the eyes. And in our case, we have replaced one eye. You could have two eyes, 3D vision, of course, and you can have an arm or two arms. And the cost has been reduced the last years for those applications, but speed-wise, it's still an issue, I would say.
Thank you guys for sending us all these questions. We have a couple of questions that has to do with money.
Yes, of course.
How do you make money today? What is your business model?
Yes.
But also in the very beginning, how did you finance the project in the beginning before you had some sales?
Well, we've done it in various ways, but there has been various research projects. Research funding has been important to us, so collaboration with universities has been a very important part for us. There has also been, I think we got some sort of seed loan in the Optisort era a long time ago, but apart from that, we have been trying to actually sell the projects, so that the customers actually pay for for most of the development. Which is not easy to do, not at all.
Yes, how do you do that?
But we were lucky.
Are you good at persuading people?
Yeah, we were lucky with the UK pilot customer we had. They had actually already gone to the Birmingham University to ask them to develop this when they met us and saw that, well, we were already some years ahead of that. So for them, they already had a budget and were willing to spend it, and then they saw that, we can we don't have to go through all the research from scratch activities. But otherwise, I would say that we have been investigating various ways. Could we rent out the equipment, pay and get some sort of service-based fee and so on, and that has been difficult. So for the moment, we're selling them as an equipment, as any kind of machine, and then we have a small maintenance and service fee. That has been the model.
Obviously, we also have some questions about AI.
Yes.
And the first one has to do with its biggest challenge. What has the biggest challenge been with?
I think the biggest challenge initially was to find the right type of neural networks. So the first we used were very, very slow. Those that we used like 8-9 years ago, they were just impossible to get any kind of speed with. But then we got our hands on some better networks, and now we're using something called a CAFE classifier. All of the software and algorithms that we use are open source, and we have just adjusted them to fit our applications.
Why did you choose open source?
Because we did not want to build it ourselves when it is not necessary. It's all out there. And we did not want to patent it either. It would not be worth it, I would say.
Some more AI questions. How did you train the AI to sort a new category of input?
Do you mean? I mean, you don't know what they mean, of course. But for any new category of input, if you look at the batteries, that is one input. Of course, you could say we take photos of a rotating battery, and then we create the data input to recognize this type of battery. But if I would teach the machine to recognize different types of leaves or different types of whatever, you just need a lot of images. And then you need to label those images. In some cases, if the shape and looks can vary a lot, you need to create some sort of automatic segmentation, which is this part where you understand what is a background, what is in the object. And then you could actually need to do a bit more advanced or detailed labeling, saying it's exactly this part of the image that is part of the object. But it's data, a lot of data collection that is key.
Because that's another question, obviously, when it comes to AI, the data question. How do you collect data? And they say the question is, do you collect data while the system is developed?
Yes, definitely we do that. We have to. For the battery customers, we come to new markets, and there are always local variations. So we have to collect new data. And we also have to do that because there are new batteries every day. We don't update the system every day, but maybe 2-3 times a year. So we have to do that. We cannot use the photos taken by the machine when it comes to batteries, because then we only get one angle. But for the fish, we can use the images that the unit produces. Yes.
I mean, I'm quite curious about, you're a small team, but when did you realize that this is something that you really should do? When was that? Did you have that moment that, well, we really believe that this is going to become something and become something big that's going to be used in different areas, in different parts of the world?
No, I get that feeling now and then.
Okay.
But then I also lose that feeling now and then.
Okay, good.
So it's because you're never certain that it will last. You don't know how long it will last. But I think now that I know that, I mean, obviously the technology is here to stay, but if it's us or all the others that will make it more scaled up, that well, I don't know that yet. I think we have looked into 2 very interesting areas, but I think there are even better applications for it, definitely. But it's a lot of, as I said, you have to have the right partnership, because we cannot invent all these different applications on our own. No.
And I think that has to do with the co-creation theme of today, how important these relationships are. And one question that I think many of the people out here actually are thinking about is, how do you actually find companies from different parts of the world to cooperate with?
Well,
how do you do that?
Yeah, I think you have to be present and as visible as possible, of course. We have been a part of different battery and electronics recycling conferences for many years, both exhibiting or speaking, and also part of these different research projects where you meet a lot of other companies, and they will tell people, as you say, you don't know who of the people you meet today will perhaps lead you to another new contact. And I think that has definitely been the case for us, that you just have to create a lot of waves, so to say.
Thank you so much, Johanna. I believe you will be here for the rest of the day together with us.
Yes.
So if you have more questions, please talk with Johanna. I have a gift to you, of course.
Thank you.
Some Mid Sweden University chocolate designed and some other nice things that you can
Thank you
use.
very much.
Yes, thank you so much.